All right, in 13.6, we're going to talk about inverting quadratics. So we're finding the inverse of quadratics. So when we found inverses before, we switched the x and y variables and then we solved it for y. And that's exactly what we're going to do today. However, I just want to give you this little note, so write this down. You are going to end up bringing in a square root. You have to put that in there. So that means you're going to have to pay attention to the absolute value bars, which means you'll have a plus and minus in your answer. And when we find the inverse of a quadratic, you will be given a restriction on the question, and that will decide which answer will be your true inverse. Remember, you can't have a full quadratic inverse because it will no longer be a function, so we have to restrict it. So I'll explain that when we get to it on these example questions. So let's just try one of these. So finding the inverse here, y equals x squared plus 2. So the first thing you want to do is just switch your variables. So this will be x equals y squared plus 2. And now my job is to solve for y. So I'm going to subtract 2 from both sides. I'm going to put my y squared on the left, so I'll have x minus 2. Now I take the square root. This would be the absolute value of y now, because I'm taking 1 out of the square root, would be the square root of x minus 2. Now to get rid of the absolute value, I need to do the plus and minus, remember? Plus or minus square root of x minus 2. Now, while that looks like I'm finished, I need to write this as the inverse notation, and I need to decide which answer is the inverse. Is it the positive or the negative? And this is where that restriction works. So notice that it is pointing to the left, so that means it's negative. So I'm going to use the negative version of my square root. So it's going to be the negative square root of x minus 2. That indicated which one is my true inverse. Okay, not both, but which one. Let's try number 2. All right, focus on the equation alone first. So we're going to take y equals 9x squared minus 4. Switch x and y. 9x equals y, 9y squared minus 4. I'm going to move that 4 over. I'm actually going to switch sides. So I'm going to put the 9y squared equals x plus 4. Remember, it changed sides with the equal sign, so it becomes a plus 4. I'm going to divide by 9. So y squared equals the x plus 4 divided by 9. Then I have to take the square root of both sides. I'm putting that in there. So y equals, when I take that y out, I have to put absolute value bars on it. So it's going to be the square root of x plus 4. Remember, this is the same as square root of 9. To get rid of my absolute value bars, remember I do plus or minus. Now that square root of x plus 4 stays like that. I can't simplify that, but I can simplify the square root of 9. That is a 3. So then it becomes, well, is it the positive or the negative that's the true inverse? Well, look at the restriction at the beginning. This one has the restriction of greater than 0, right? Greater than 0 indicates the positive. So I want the positive answer. So it's going to just be the square root of x plus 4 over 3. Let's look at number 3. Y equals x minus 6 squared. So switch your x and y's. So x equals y minus 6 squared. And remember, we're solving for y. So I'm going to switch the sides of the equal sign just to keep my y, what I'm solving for, on the left. Now I want to get rid of the squared, so I'm going to take the square root of both sides. So when I do that, I have to take the absolute value of y minus 6. That's what comes out, right? Equals the square root of x. Now, to get rid of the absolute value bars, I have to do plus or minus the square root of x, right? Then I'm not finished. I need to isolate the y. I need to move the 6 over by adding 6 plus or minus the square root of x. Now I'm not finished. I need to apply the restriction. Again, it's pointing to the right. If it's pointing to the right, I want the positive version of this answer. So I'm going to do the inverse notation, and I'm going to do 6 plus, use the positive, square root of x. This is my inverse. All right, last example. Again, we're starting by switching x and y. So x will equal 2 times y minus 4 squared. And we're ultimately solving for y. So I'm going to start by dividing by 2. And I'm going to switch sides like I did before. So I'll have, when I've divided by 2, I will have y minus 4 squared equals x over 2. All right, I just switched them up. Now to get rid of the squared term, I need to take the square root of both sides. I'm taking an odd number out, so I have to put that in absolute value bars, and I will have the square root of all of this, x over 2. Now to get rid of absolute value, I'm going to take the x minus 4 and set it equal to the positive and the negative square root of x over 2. Now, I'm not finished. I can move that minus 4 over. I can put it in the front or the back. It really won't matter. Let's just put it in the back this time. Plus or minus the square root of x over 2 plus 4. Now I have to decide, is it the positive or the negative of the radical? We'll go back again to the restriction. This one is pointing to the left. It's positive. That means I want the negative version. So my inverse will look like this. Make sure you use correct notation. Negative square roots of x over 2 plus 4. There's my answer. All right, good luck. We'll see you in class. Thanks for watching.